Hello, everyone. Today we have here Professor Beckman, a computer science professor here at U of I, to talk to us about computer education and different programming languages. So Professor Beckman, take it away.
Thank you very much. So I'm Mattox Beckman, and I'll just say a little bit about who I am and how I ended up at the University of Illinois. It's kind of an interesting journey. I was actually a student here for a long time, and then in 2003 graduated and moved to Chicago to teach at IIT. And then in 2015 was asked to come back to the university to teach here. Been very happy to have done so. Now, my research areas are a little bit interesting. I was trained in programming languages, and about 2 years ago now, maybe 2.5 years, decided to change tack entirely to be CS education. So I kind of have these two things going on. I'll talk a little bit about both of them. Now, my professional interests are, of course, are teaching, computer science education, something called functional programming, and a bunch of other mathematical sounding things. And I have a lot of personal interests too. It's something I've become a little bit known for. If you see this presentation some other time or take a class from me later, this list will be different. But today, the list is mindfulness, meditation, and homebrewing. And there's this wonderful ancient game called Go. And there's a bunch of other stuff that is there as well. But just one of the things, having many, many different interests, personally, professionally, it means you get to try a bunch of different things. And so it's kind of influenced my own career as a computer scientist and just even being as a person. So let me talk about the two research areas that I have played with. One is the programming languages, which is my training. I still enjoy very much teaching a programming language course. I do a little bit of research on it, not a whole lot. My main job here is teaching, not research. But the way I like to introduce it, why should we study programming languages, is this word Paisei. Now, it's not a very common word. It's a Taiwanese word. If you happen to know Taiwanese, then you may have recognized it. Other dialects of Taiwan or other dialects of Chinese, let's see, in Mandarin, it's bu hao yi si. And in Cantonese, it would be something like, I think, hak hei. And it's actually, if you wanted to translate it into English, you might use a word like bashful or embarrassed or something like that. And it's not wrong, but it misses out on so much of what's going on. One of the best translations I've ever seen from this, I was watching a Jackie Chan movie, and the audio was in Cantonese and the subtitles were in English, and they were over at someone's house and they said, don't be hake, the Cantonese version of it. And the subtitle, they said, make yourself at home. And that was perfect. There could not have been a better translation for the word at that point. So what is Paisei? It's kind of a cultural phenomenon, much more common in the Asian part of the world than in the Western part, I suppose. But the way I like to explain it is, if you ever go to dinner at Chinatown and you see two families having dinner together, they good friends, they enjoy each other's company, having great food. And at the end of the meal comes a point where it's time to pay. And for whatever reason, just splitting the bill is not how it's done. Someone has to carry the whole tab. And so there is this glorious battle over who gets to pay. They're fighting for the ability to pay for the meal. And now, mind you, they might not necessarily want to pay for the whole meal, but to be polite, you have to at least make a good show of it. So, one person pretends to go to the bathroom, but everyone already knows that trick, so they get an escort. They go back and forth explaining why, no, it's my turn. You did last time. No, that kind of thing. I've literally seen, when I was at IIT in Chicago, it's right next door to Chinatown. So I was eating there and literally saw one person blocking another person from the register with their body, while a third person runs around the both of them to get to the person at the cash register, who's just sort of calmly waiting, because it's just how things are done. So eventually someone is able to pay. Someone gets it, they win, they go home thinking they win. And then one of the kids reaches into their coat pocket and notices that someone has stashed in a whole wad of $20 bills. So this is paise. So, if I'm with a friend, I want to treat the friend and they protest, I might just say, don't be paise. Just say, okay, just let me do it. It's fine. So the reason why I bring this up, the reason why I introduce programming languages with this word is in English to an audience, like an audience that was raised in America who has really not experienced this. It takes, I wasn't timing it, let's say 3 minutes, 5 minutes to just sort of spell out what's going on with this word. But, if you grew up learning Chinese or a similar language, it's just 2 syllables. You've got it. This is part of the culture. So a word was made to explain it. And it turns out that computer languages have a very similar dynamic going on. Certain languages were developed by people who had certain kinds of problems to solve or certain ways of thinking about the world. And what they did was they developed a language which made those particular kinds of things very easy to say. And the reason why I like to emphasize this is that historically, at this time, the main language people will learn is from one language family. So human languages come in families. When I was in high school, I took 2 years of French and 1 of Spanish. There weren't very many language study opportunities there, so I took what I could. And I noticed I could read Italian and pretty much make sense of what was going on. Couldn't really speak it, but I could read it. And that's because those 3 languages are in the same family. And programming languages are the same way. If you learn C++, you can probably learn Java pretty quickly. But if you try to learn another language like Haskell or Lisp or Prolog, and these are languages in a different family, it's going to be much more difficult. And so for me personally, my wife is Korean. And so trying to learn Korean, knowing Spanish and French, even just a little bit, has helped not 1 bit in learning Korean. The sentence order is different. The sounds are completely different. I mean, they sound like the sounds you're used to, the vowels, but they're not. And after some training, you learn to distinguish between them. And it's like, oh, this is really hard. So it's knowing that our students these days only see 1 kind of programming language. So they only see the languages that are in the C++ and Java style families. And JavaScript's one of them. Most languages that you've heard of are probably in this area. I want to show them what else is out there in the world, because there's some really cool things that you can see, really cool ideas. One of them is Lisp. There's this, one of the founders of computer science is named Dijkstra. If you Google EWD340 and probably Dijkstra's name, you should be able to get this. But he talks about Lisp and says it's, this quote here, it's an excerpt. He has some other really interesting things. One of them is the most intelligent way to abuse a computer. But what Lisp allows you to do that most languages don't is Lisp allows you to program itself. The language is actually programmable. And it's just mind-blowing when you learn how to do this. So these are sort of things I want students to understand, to have this experience. And so one day, maybe they're on the job site and they come across a problem and they remember, you know what, we could spend 2 weeks in C++ getting this to work, but I remember that it only takes about 15 minutes to do this if you're using Prolog. Maybe it's worth their time to download a Prolog tutorial and see if we can hook something up. Another really interesting thing that happens with languages is that as time goes on and computer scientists become more understanding of what it is to program. I mean, mind you, we've not been doing this for very long. The oldest language, Lisp, that's still used is something like 62, 63 years old. We're just figuring out what we're doing here. And so when a new language comes, it often has features that if you see it and you're not used to it, you're just going to think, oh, that's kind of weird. That looks kind of strange syntax. I wonder what that's for. And we call this blob. So imagine your favorite programming language is Blob, and you're looking at another language which obviously is not as powerful as Blob. Then it's usually very easy for you to recognize that. You're like, oh yeah, it can't do this, it can't do that. But if you look at a more powerful language, you're not going to recognize that it's more powerful. You're just going to see that it's really different. And there's probably a good metaphor for life about that. If you see something you don't quite understand or looks strange, maybe you should ask some more questions about it and try to understand it better. Now, the other thing that I'm really into, this happened about 2.5 years ago now, I was at a conference, and it really convinced me that CS education is what I should be studying. Now, I've always wanted to be a teacher. I live for the time when a student goes, oh, I get it. I mean, that for me is everything. And I've always wondered, okay, what is that final step? What helps people get that? Sometimes people get it right away. Sometimes they really struggle. Sometimes you just say the right thing and all of a sudden it clicks. It makes sense. And so I always thought, well, just as a teacher, I will learn how to do this and, learn some things. I like to think I'm getting better at it. But at this conference about computer science education, I realized if I could research about this, learn more about what really happens to make these light bulb moments occur, and if I could show other people how to do that, it would make a lot more impact than studying partial evaluators and lambda calculus, which is what my PhD thesis was about. And you can live a long and happy life never knowing what that term meant just now, and I will give you the chance. But yeah, get in touch if you really want to know. But I decided, yeah, my life would be more impactful if I study that than if I stay with programming languages. And the other thing too with CS education is where the studies show that if you haven't picked it up by about middle school, it's not as likely that you'll even get into it or consider it. And so I feel like there's a lot of people who don't even try it, don't even think about it, where it could be a really rewarding career for them. And I just want this opportunity to be out there. I mean, if you want to study something else or do something else with your life, that's great. But I think it would be terrible if you didn't even know that this was an option. And so for me, CS education, and this gets into issues of things like diversity, inclusion, just making this resource available to more people is something that I'm becoming more and more passionate about. Now, one of my specific things that I've been researching, and you may already know this, I understand that the target audience for this is mainly people in high school, and high schools have adopted this in certain areas. It's called Pogol, process-oriented guided inquiry learning. And it's a very interesting way of doing an in-class activity. Well, I guess it doesn't have to be in class, but that's how I usually structure it. You have these 4 roles where every person does something a little bit different. And, this, when I was in school, if you did a class project, flip a coin, lands on head, the team is going to, the way they're going to operate is one person's going to do all the work and everyone else is going to copy it all down, right? So naturally, that's not what we have in mind as teachers. So with these different roles, we're emphasizing the process of working together, asking good questions, checking each other's work. And so I have been asking the question, what is it like to apply this to upper level CS courses? My programming language course usually has seniors and graduate students, and I have not seen any evidence that anyone has tried this technique on that level. It's typically, chemistry department uses it a lot. It's used in high school and beginning courses, but at the upper level, it kind of drops off. And my theory about that is it just isn't discovered. There's a quote from, I think, Euclid, way back in the BC era. He was saying that there's not much new to discover in teaching, but most people don't know the old ideas. And so for me, I feel like I found an old idea. It's only 20 years, so maybe it's not really that old, but I want to apply it to a new place and see what happens. So, of course, I started doing this in earnest last semester, then the pandemic hit. So like everyone else, we're on Zoom using breakout rooms and just trying to see how can we make this work? What can we do to have a good sense that people are interacting with each other, even though that we have all these weird constraints, which, they're a real pain now. They won't last forever. But what can we learn while we're doing that? So that's my main thing about CS education right now. Honestly, I'm really on the ground floor with this, just trying to learn how do you do CS education research. I know how to do programming language research. So I'm starting from scratch. It's really exciting. And come ask me again in 5 years if you can find me, and I'll tell you what else I've learned. But that's pretty much all that I have here for the slides. So I'm just going to back it up to the beginning. And thank you very much.
Great, thank you. I have some questions here, actually. So you touched upon this earlier, but how would you say that learning a programming language is similar to learning a language in the real world? So, for example, do you think that there is a critical period for learning a programming language like there are critical periods for learning languages like English or other languages?
That's a good question. I don't know if there's really a critical period, but I suspect that there might be something like that in play. What I mean is, I feel like if you were in high school or junior high and you learn how to program, I feel like it will come more naturally. I don't know. This is just a guess. Completely no evidence to support this, just own personal reflection. My wife now is actually, this very week, has started trying to learn a programming language called Python. And if you just told me, hey, I'd like to learn to program, what should I do? I would just say, yeah, try Python. Like the snake, just Google Python programming tutorial. Everything you need will be right at your fingertips to get started. It's a great language because it's easy for a beginner to learn, but you can literally make a career out of just this language and have a full-time job programming it. But one thing about the critical period, I mean, if you pass critical period and then you try to learn a human language, you either, I haven't seen studies lately, but the one I did, it was maybe 20 years ago, they said the trade-off is you can achieve native fluency, but you probably have to give up your native language to do it. It's really difficult. And as an adult learner of Korean, whose native language is English, yeah, it's hard. But the nice thing about programming languages, though, is that they're not nearly as complicated as human languages, right? There's only a finite number of language constructs. You eventually learn what they all are and how to use them. And now you've mastered that language. And you can always learn more algorithms, more ways of programming certain kinds of programs, but everyone's doing that. So that's, yeah, I feel like with critical period, you don't have to worry about that quite as much with the programming language, because maybe it takes you a little bit longer. I don't know, but a little bit longer is more like 6 months instead of 3 if you decide, yeah, I really want to learn how to do this. The other part, though, I don't know how long it takes to learn this other bit, though, is just computational thinking. It's one thing to be able to write a computer program, but knowing how to think through that process of what computation is, that's another part of it. And it's really hard to measure what's going on when people are learning to think this way.
Yeah, and kind of piggybacking off of that, there are many people who say that CS is a innate skill that you need to have in order to program. It's something that if you either have it or you don't have it. Would you say that learning CS is something that people can pick up regardless of who they are, or would they need to have this like innate skill to do it?
So I am a very strong component of something called the growth mindset. Most most attributes you have as a human are malleable. So, I mean, the few things that are hard to change, you can't probably change your height or a few other characteristics of your body, but almost everything else, and in particular, intelligence is something people used to think, you know what, this person's kind of smart, this person's kind of not smart. That's just the way they are. And the thought was you get a certain amount of intelligence and your job is to apply that best you can. And it turns out that's false. It turns out intelligence is not like your height, it's more like a muscle that it will respond to external stimulus. It can grow and actually can shrink. And I think programming ability is this way as well. Obviously, someone who's never touched a computer, never tried to do this, they're going to struggle when they first happen. Um, so one of my hobbies that I didn't list on the page is I am into weightlifting. Haven't been doing it that long, but long enough to notice a huge difference in my life. Um, when I started out, it was a struggle just to lift the bar. And I remember a certain weight. I remember the time I loaded the weight up with 190 pounds and rested on my shoulders. I didn't dare try to lift it. I just wanted to feel how heavy it was. After a certain amount of time, that 190 pounds was just one of the warm-up sets I would do to get to the actual weights that I was supposed to be lifting. Programming is the same kind of way. And I've seen this happen in my own programming. If I leave a language for a long time or a certain style of programming and then come back to it later, it's a little bit fuzzy. It takes a while to get back into it. Once you're back into it for a while, you pick it up more quickly. So it really is one of those things that success brings success. Now, it is true there is different level of innate ability. You start off with a certain amount and that will change how quickly it takes for you to pick it up. But definitely, I do very strongly believe if it's something you just say, yes, I want this, I'd like to know how to do this. And the motivation is very important. If someone's making you do it, if you don't have that internal interest, then yeah, it's going to be rough going. But no, I really believe that pretty much anyone can really learn to program. And whether or not that's necessary, I honestly haven't decided. People talk about CS as being another form of literacy. And I'm not sure if I would put it that far or not. It may well be that. At least one thing that's going in favor of that, though, is that so much of our society now is based on computation. You know, a lot of policies are algorithms, and having an algorithmic understanding really does help you to understand what's going on with that. I'm not sure if that answered your question well, but
No, yeah, it did. And I also wanted to back up on that. And how do you think that, you mentioned this briefly, like diversity and inclusion would relate to that concept of anyone can learn how to do CS? How would you feel like those are related to each other?
well, so where to begin? So okay, there's a couple things at play here. One is there is a certain stereotype of what kind of people end up into computer science. You know, I'm talking racially and gender, and there's good reason for that stereotype is because it tends to be dominated. And as a result, people who may not really identify well with that, you feel discouraged. I mean, especially like in a college program or in the workforce, a lot of society is designed to show you the people who succeeded. And the people, if someone doesn't succeed at something, they're not necessarily going to broadcast that, right? And so when you get to a new location, whether that be a university or a job site or wherever, the only failures you're likely to see are your own. And so it's easy to assume, well, maybe I don't belong here. Now, if you also feel like you're the only one of your kind or the only one who's like you, and that feeling is magnified tremendously. And so that causes sort of a feedback cycle, right? You know, if you're from Inlagenia and you're the only one in your class and you're struggling, it's easier for you to assume, well, maybe I just don't belong here. If you have three other friends from Inlagen, it's a made up country name, by the way, then it's easier to like, okay, you can talk to each other, you know that you're understood, and it's just easier to feel like, okay, I can stick this out. So you have that kind of resource.
Yeah.
Um, so just helping attract more people to this career, because like what I said earlier, this is an amazing career. It's a tragedy if someone misses out on this when they could have thrived in this because they didn't even think it was an option for them. And so that's for me where one of the angles of about diversity inclusion. There's another really huge angle. If you have a team of people from the same background, they are going to produce objectively worse programs, products than people with diverse teams. It's easy to prove. I mean, if you go to your web browser and do an image search on grandmother, should probably make sure safe search is on or something. But if you're not a white person, the images you get are not likely to look like someone that you would think of as your grandmother. Facial recognition software is a really big example of all of this. If you have, so like a bunch of white programmers in America, their facial software will recognize white faces. It won't recognize black faces. It won't recognize Asian faces. If you go to China, have a team there make facial recognition software. It will recognize Chinese faces, but it won't recognize white faces. If you have a diverse team, you're more likely to have different viewpoints, different thoughts. You're not all trained to do the exact same thing. You're going to do things a little bit differently. So you're going to end up getting a good solution much more quickly than a homogenous team is going to. And so that's the other reason to think of diversity inclusion as good for society. I mean, even if, I mean, the moral reasons of just having opportunities available to people is good enough, but there's something in it for us as well, that everyone is better off if we can make this happen.
Yeah, and I definitely agree. I think it's something very important to keep in mind. And one last question I guess we could close off on would be, to someone who is in high school who is looking to get interested in computer science or possibly even doing what you're doing, computer science education, what would you recommend for them to do? How would you recommend them to get started, and what skills would you recommend them to focus on?
Well, if they have access to a computer, that helps tremendously. But I guess I would give the advice I would give to other people is start off learning how to program in Python. Just Google Python programming and see where that takes you. Probably another skill that is good to have. It's not 100% necessary, but it does help to do what you can to improve your math background. Not everyone's going to need it. You're not probably going to need calculus, but learning how to think about numbers and how they work together is one good way. If you've gotten to the point where you feel like you are understanding how to program, one thing that I would actually recommend is to do something called competitive programming. So you can go to these websites. They have contests. You don't have to participate in the contest, but you can get, so there's this book I have called Competitive Programming 4. I don't know if you can see it. And in there, they explain how just what it's like to program in a competitive environment. Now you might be thinking, oh, no, I'm not going to compete. I don't want to do that. I'm not a competitive type. I'm not either. I hate conflict, competition, whatever. But I find programming under a time limit helps me. It pushes me to get better. And it kind of goes back to that mindset thing. If you want to get stronger, you have to lift weights that are a challenge that you're going to struggle with. And so if you're learning to program and maybe this competitive programming is not for you, that's fine. But try to think of challenges. Try to think, okay, I've learned some Python. Now let me see if I can write a program that does blah. And one of the beauties of Python is it's been around for over 20 years. There are plugins and modules and stuff you can get to do almost anything you can think of. If you want to learn data science, yeah, there's data science plugins. You want to set up a website, there's a module called Flask. You want to do a database, there's a database plugin. I mean, it actually comes with the language. You don't even have to plug it in. But start to think, hey, can I write a program to do this thing? Or can I make a picture out of it? Or maybe look up fractals and see what fractals you can make with Python. That will give you something interesting to do. And it feels great when you get something working that you've been trying to get working. For me, when I was in high school learning to program, my thing was I really loved text adventures. So, the computer says, you're in a cave, there's a dragon sleeping on a pile of gold. What do you want to do? And you type go north, and it tells you what happens next. Those aren't that hard to write. If you're interested, look me up. I can teach you how to do it. But yeah, just something like that. Just give yourself little challenges to work on, and you'll be surprised at how quickly, once you learn a new component, these things can be combined. So if you learn how to do a website and you learn how to make a database, well, you can have a website with the database as a backing it up. And now suddenly your website's not just a blog, it's a product catalog or something like that. And these things multiply together when you combine them. And that's one of the beauties of computer science that I hope people get to see.
Thank you so much, Professor Beckman, for speaking to us today, talking about computer science education and how people learn computer science and why that's important to not only those people learning it, but the world as well. So thank you very much.
Yeah, it's a pleasure being here. Thank you for inviting me.